Okay, hello everyone. I'm going to introduce Dr. Ben Martin for this first talk this morning. Thank you.
It's almost like my work is done immediately. So I'm talking about FileSender, which project that I joined as maintainer sort of a little bit under 2 years ago. It had been already released. I think the project's about 10 years old. I get into the languages and databasey sort of stuff, but it had been sort of sitting for a while, and version 2.0 was sort of wanting to be released. People were still running 1.5, and there was encryption, end-to-end encryption added after that. But a lot of places wanted to have a version 2 release before they were willing to actually test that out. So you had that, or you had people who were running the alpha straight out of Git, which is not, an ideal situation. FileSender is used, well, is it used, and where is it used, and does this laptop, yes, there we go. The green countries, the National Education Research Network. So for people from Australia, this would be AARNet. Throughout all of those countries, they have a FileSender deployment, and it's made available to universities. So if you're Australian and you have a university login, you should be able to use FileSender basically now. So you don't actually, the great part is that it's browser-based, you don't have anything to set up, and you can just sort of go for it. And there's all of the features I'm talking about will be available to you. This is what you get to see. Once you log in, the upload page basically shows you how much of your quota you've got, which files you're choosing to upload from your desktop or laptop. And you can have end-to-end encryption, what your password is, or have the system generate a password for you, and a bunch of other interesting options. One of the things people say when I talk about large file sharing is, hey, I can set up Apache or WebDAV or anonymous FTP, or just use SSH and rsync. This is a solved problem for me. And I say, well, that's kind of interesting if I'm at a conference like this and I meet someone and I say, you have a research file set that I'd like, and you're willing to share that with me to write a paper. Most people aren't going to sort of say, oh, here's an SSH key, I'd like to put this on my FTP server. In this case, I can give you a password. If I write the password down twice on a napkin, tear it in half, give you your copy of the password, send you a link as a guest to my FileSender server, and you can upload, and it'll only come to me. And once you've uploaded, I'll get an email saying that file has been uploaded, and I'll have a designated, say, 30 days to get it. The usual installation of FileSender is for sharing a file. If you're emailing a file, it's 100 meg to someone. The default sort of setup is that you've got about a month, and then the file gets deleted. So if you're emailing them, it will say to them, you've got a month to get this file, and you'll get an email when they've downloaded it. So you get a lot of admin sort of things that you wouldn't necessarily get if you just set up a web server or FTP or whatever. Especially limiting people who are uploading files to only come to you. And that would be in a small group. Multiple people can do that, and you don't have the problem of sort of anonymous FTP and who owns files. Once you upload the file, you go over to the My Transfers page, which again gives you all of the data on how big each file is and when they're uploaded. And you can page through, and you can click on the audit icon to see exactly what's happened to each file, how many times it's been downloaded, who downloaded it. Depending on the configuration of FileSender, the IP addresses can be masked there because, again, GDPR, like you may not actually want to have people knowing whose IP address it is, who is downloading it. There has been updates for GDPR in this. The configuration, the number of days things are done, are retained, information about the user, generates a page explaining all of this data to the user of the system, so they're aware of what you're doing on your side. And there are installations, instead of having the server just delete the file, that actually runs shred on files. So, if they're quite paranoid that the file, someone's going to swoop on it and take the server, it makes it a lot harder for anything to be recovered. So from a user's point of view, you only need the web browser. You can set up a server fairly easily. You need a web server, a database, Maria or a Postgres. The main thing is the upload resume feature. The big selling point is if you have a file that's multiple terabytes big, you can add it in your browser and say, just upload that. And if your internet connection goes away for 5 minutes because you're on a laptop and your Wi-Fi dies, you won't come back and see a nasty message saying, by the way, that's failed. You'll have to start uploading again. I got like halfway through, but start again. You'll get messages saying your Wi-Fi went down for 5 minutes at this time. Afterwards, I tried again. Wi-Fi was up again. I uploaded from there. So that's configurable, so you can have it try that 50 times. Because the whole idea is that once you've set up the file, set up your options and click start, you want to be able to just walk away and come back and see or get an email saying it's succeeded. If you want, you can quit that browser window, reopen the browser again, and it'll say you were halfway through uploading the file or whatever percentage it was and continue from there. You can close your laptop down, go to your desktop machine, and it'll say, hey, you were halfway through. Do you still have access to that file? Would you like to resume uploading from that 50% and continue? So you should never actually lose a partial upload because, again, it's designed for being able to upload large files. So losing a partial upload is one of the worst things you could possibly do. One of the side points when I talk about this at Linux conferences is that the authentication uses SAML, which is great if you're a large research network because you have SAML endpoints and you can sort of hook up 100,000 user database and everyone's happy. I have information on the website if you want to set up reasonably simple password authentication rather than doing that. And again, there are reasons you might want to do that just with a small, or if you have 5 people that you want to be able to use this with, because if I have my own FileSender running at my place, again, I can send anyone in the room a guest token and they can upload just to me. And they don't need to worry about SSH keys or anything else or authentication. So you can use the system, even if you're not using it as the user password part, the guest token part makes it still quite a useful system. The GDPR by default, and there are some organizations in Europe who sort of take it well beyond GDPR. So say shredding content and things like this. They've even disabled the admin page so that the site administrator for FileSender can't see information about who's uploading files. Quickly deleting logs. Everything in the database that's logging information has a sunset, so you can say only keep this particular information for 30 days, and that way you're not responsible for trying to protect that if there's a leak. Server-side codes, PHP. There's a very light sort of widget set thing in JavaScript. You get the choice of Apache or NGIX, as I said, the SAML authentication. I had targeted later MariaDBs like 10.2, 10.4. The CI system now runs on 10.0, just because as soon as you have things like view definitions with subselects, I think that was the case where 10.0 decided it didn't want to do that. So the CI is targeting the minimum version of MariaDB. Configurable size chunks in the browser. It uses the blob splice, which most browsers support in some variant. This particular detail is a little bit hidden from users, but from a system administration point of view, comes in quite useful. If you're uploading and the upload fails, you may lose part of a chunk, but every time a chunk is completely uploaded, it gets committed. So if you have 5 chunks simultaneously uploading because it supports parallel upload, you may lose 20 megs of your uploaded data. There's multiple ways, because it runs in the browser and it's web-based, there's multiple different paths to upload a file. Upload a single whole file, use REST clients. TerraSender is a pure JavaScript web worker implementation, which is the default choice. And you can choose to allow it to upload just one file or multiple files at once, and how many parallel uploads happen. So you can have 10 parallel uploads running over 2 different files, and it will, if you have 3 files in the upload screen, it'll show independent progress meters working at the same time. The server storage side of FileSender is virtualized. Arnet use Ceph to back their storage. Some people are wanting to back the storage with the cloud-based stuff like Azure and S3. I added chunk storage so that the fragmentation was a bit less of an issue. Because if you're only having 4 or 5 meg chunks, if you delete a file, you all of a sudden free up those chunks, and then when you upload a new one, you can reuse the same chunks. So in theory, it shouldn't fragment as badly as having everything stored contiguous on the server as it was on the client, because you don't have random file sizes. For downloading, you can either grab 1 or 2 or enter your password and individually decrypt files, or if you have multiple files, you can just download a zip64 containing them all. I did that with the PHP streams, so it's a virtual zip that's created on the fly, which also means that in the future it'll be a virtual tarball so that it's not as nasty on some platforms. Zip64 seemed to be sort of the default choice. Unfortunately, on OS X, Zip64 doesn't work with the native zip client, so you need to tell people if they're downloading large zips, which I force every zip to be large, because inevitably if you don't, someone will download a 1 gig zip and they'll see that it works, and then they'll download a 5 gig zip and see that it doesn't work. So if they're all Zip64, then it doesn't work for everyone unless they put a Zip64 client on there. Yes, so why wouldn't you want to write a FileSender yourself? That's the good part. Trying to get things to be robust in JavaScript. It all works fine if you've got just Firefox and it's just the latest version. But then you find that some system administrators decided to lock down some of the JavaScript calls for all of their people on their network. And you only hear about that because uploads don't start. And the progress meter sits there and the JavaScript just sort of drops out because it's been denied. And the number of different browsers. Currently the most painful combination, which is seemingly common use in some places, is IE 11 and Windows 7. I wouldn't have really thought people would still be running around to use that configuration, but it makes for interesting times. The end-to-end encryption uses the W3C web crypto API, and there's a bit of discussion currently about whether that's the best desired outcome. So if anyone is a web crypto or JavaScript web encryption sort of person and wants to have a chat, then come and see me and we can have this wonderful chat about JavaScript libraries and encrypto. Everything you do in the database, you'll find somebody who's using an old version of the database. I think I had people coming forward and saying, hey, you've added views and that's great, but I'm using MySQL from 10 years ago and it doesn't work. And don't do that. But they seem to think that that's a great choice. And things like this sub-select in views thing, if you're using a recent Maria, it all works for you, but it won't work for other people. The current database design, I've moved. The SAML ID is actually the email of the person who's authenticating. And that used to be the primary key of the user table, which was for many reasons not a great idea. If you create the table with UCS4, then every character is 4 bytes, and you have 170 bytes for the email address. So you're sort of losing a 1K on the primary key, which, speaking of fun database things to do, migrating databases and moving IDs to their own table and then creating synthetic IDs throughout tables and migration scripts, that's a hoot. I'd recommend doing that if you have large users who are in other countries who have 100,000 users, because you'll get interesting times from that. Mostly the migration for that worked. It didn't work in one case because there was a permission issue, so the migration didn't fully work and needed to be attended to afterwards. The main tables involve transfers with multiple files, and you can tag recipients or you can not tag recipients. Again, people sort of object to, if you're uploading a file and you want to say, send this to Tom at this address, people object to that privacy infringement of saying to a system, here is an email address, because they think, there's some harvesting going on, which is probably rightly so. So you can also upload, and if the system administrator has allowed you to do it, you can just get a HTML link, so you can then email it or send that however you like, and the system won't know who you're sharing those files with. Again, privacy of the users is sort of the top mandate of the project. And there's a bunch of secondary tables with logs and audits and stats. The client logs table, basically if something goes wrong on the client side, there's a dialog that pops up and says, hey, this has failed. you're obviously going to know about it. Would you give consent to actually sending some of your console logs to the server? And only after the user gives the consent that they're sent over to the server so we can try and work out what went wrong. Collections and file collections is an interesting feature. There's the ability just to drag a whole directory and upload a directory tree in FileSender. Somebody from the US wanted to disable having the files purged after 30 days and use this for archival purposes. So in the storage side, instead of storing chunks and things like that, he was storing that basically how he wanted to have it sort of permanently stored, and allowing people to use whatever hardware they were using to upload large directories of files that were permanently kept. So quite happy with that, and quite happy to accept contributions that change the way in which FileSender is going to be used, because the backends are all virtualized. And in this case, the directory upload was a contributed patch because that was a feature that he was looking for. I've sort of touched on the fun of database stuff. When I first joined, there were no views or foreign keys being used, and also no secondary indexes. So if you had a really huge database and you uploaded something, I think for some people it was taking 25 minutes to show their list of transfers, and now it's down to seconds because that's what it should be. I understand that there are reasons for this to be the case before I joined, in that the databases being used at the time didn't support secondary indexes, and this is also partly why the email address was the primary key in the user table, because again they couldn't index it if it wasn't the primary key. So there are interesting, valid reasons why things were how they were, but now they're how you'd expect them to be in some cases. The association between users and guests needs to be a bit cleaned up, and the transfer options, which are the things like whether you wish to encrypt things, or whether you want to get a link, or whether you'd like to send it to email addresses, is actually stored in JSON in the table, which is from a database point of view, it's not great. So that's probably on the radar to be fixed. Which object relational model does FileSender use of the many PHP files, ORMs? And of course, the right answer is its own ORM. So it's all described in, it's not actually too bad. You get to decide in tables what data you want to have, and there's migration scripts to add new fields to the database. And unfortunately, from there, you get into the point where you start adding your own stuff so that you can handle different numeric types, and you can smooth over the fact that different databases don't have the same date diff thing. This is all a great pitch to get people to join the FileSender project. Here's all of the pain points that you can expect, and patches accepted. But yes, their pull requests will be accepted if they're put together fairly well. But hopefully you won't have to do that. But you may be interested in how things all work. There's just the aforementioned date diff function, because Postgres and MariaDB do this differently, and you need to handle that sort of thing. So the TerraSender, which is the web worker thing with multiple parallel uploads, just sort of an overview of how that's happening in FileSender. Here we go. So at the start of an upload, a number of web workers is created, and the web workers all fire off, and they're told which byte range in the file is their current chunk, and then they use blob splice to grab that current chunk, use a XHR to send the current chunk to the server, and wait to see whether or not the server says, hey, that was great, or that was a no-go. If it's a no-go, it signals that back, and it keeps retrying it. So there's a number of retries for those no-goes, and there's also, on the wrapper of the whole upload, a number of retries. So if you are getting 20 or so retries on one chunk that fail, the whole transfer has failed, but then it'll automatically resume the entire transfer from where you started off, less the part of the chunk that you had uploaded. So again, the pressure is in the system to keep retrying without any human interaction to actually get the whole file uploaded, because that's the goal, rather than sort of popping up a dialog saying bad things happened. And even when that happens and it says bad things happened, you say, that's great, reload the upload page, and it says you were 70% through uploading that file. Would you like to do that again from the 70%? So Again, an email to the mailing list or the GitHub issues if you have any cases that you can get information on where it's not resuming properly. They're issues that I'd really love to fix if they are still there. So, where are we? Halfway through. So if you're at all interested in looking at the JavaScript to do the FileSender upload or have ideas that may improve parallel upload, WebSockets was one that I was thinking of rather than using XHR to do upload requests. But at the moment, the work path goes through, creates workers, and sends a start message to the worker. The yellow thing is basically sending to the worker, and then it requests a job back from the main interaction thread because web workers can't really do much by themselves and can't share state. So all it does is says, what would you like me to do? And the main thing basically sends a command back saying, here is your task, if there is more tasks to be done. Otherwise, terminates. There was also some interesting gotchas there because when it was going through, there were a number of times where the very end chunk of files was not being uploaded properly because of subtle race conditions in timeouts and wait states and callbacks. So that's hopefully no longer there, but that was the amusing bugs that can also be discovered. This sort of gets back to the why don't I just write my own JavaScript that uploads large files, because that's really easy, and then it's not. So I thought better of including that specific low-level example. When the worker's executing the job, the data is optionally encrypted before doing an XHR send, and then basically if you get a message back or an error back, it sends that back to the controller to say, hey, that chunk's done, give me another one, or hey, there was an error there, something bad happened. And there's a fall through, yeah, that's sort of what I was saying. Move on. So the security, there are a few edge cases in the security that I'd like to be cleaning up. When you're encrypting files, it all happens in your browser, and the decrypting happens in the other user's browser. The server never sees unencrypted data. You can either choose your own password, and minimum lengths can be enforced on that, or you can have the system generate a password for you. Password sending is not handled at all by the system. There's talk about using PKI for that, but of course this is used for research facilities, and they're not all IT. So if you have two chemists wanting to share a large data set, they're probably not going to be interested in what's PGP and how do I spend my weekend learning about that. They're much better off saying, again, meet another researcher at a place like this, at a chemistry conference, write the password twice, you take yours, I take mine, and we know that we're going to send files to each other. Or we share 5 passwords at a time. So the password sharing part is currently still left up to the users to do. The current crypto, each chunk gets its own 128-bit IV and AES 256 CBC. Combination, if you have the default setting is to use import key and derive key. There is no derive key in the Explorer 11, so you have to force the key version of 0, like the older keying style, if you want to support AE 11. There's good reasons why you would want to use derive key rather than just import key, mainly if you're using passwords. And you're generating a new encryption key for each chunk. Depending on how many hashing rounds you're using on a password, that can take a long time. If you're using few hashing rounds, you may get security for a couple of years, or expect to get security for a couple of years against a brute force attack. But on the other hand, it takes a few seconds. But if you want to extend that to 10 years or something like that, you may expect to take a minute to actually hash a password. So if you can't use something like derive key, you have to do that for every chunk. So you've added a 1-minute delay per upload of every chunk then. Whereas if you can do that just the once, like hash the key once and keep using that to generate the keys for each chunk, there's a huge efficiency gain for larger security. Some may argue that for larger security, you shouldn't be using user-generated keys because users generate crap keys. But I prefer to allow people to shoot themselves in the foot if they choose to do that. Some of the near future things for the encryption are, because if you generate the key using pure entropy, you don't actually need to hash that because it's already as random as it's going to be. And that's not so much coming from me, but from a crypto expert in Europe who was commissioned to do an audit on the code to make sure that there were no huge gaping holes in it. So that's handy to know that the AES-256 doesn't have, he didn't come back and say the whole ship's on fire. He came back and said, here's a list of things to fix. So yes, generating the keys, and instead of using base 64, which is the lower one, using something like the bubble babble so that people can pick up the phone and say this is the key, and rather than saying, oh, it's capital J and the 9 or whatever, it's all going to be lowercase and it's all going to be somewhat easier to communicate over a phone, although at the expense of being longer. Ultimately, maybe having the choice because they're all going to decode to the same key. So, I'll choose, but then it then becomes another issue of if you show the user 5 keys, they're going to say, oh, it's key number 5, whereas you tell them it's all the same key, and it can get, you can present too much information to somebody who just wants to send a file, which is the main objective here. There is talk of instead of using CVC, because if you're using AES-256 CVC, which we currently are on the server, someone can come in and put a crap block in there and the CVC won't protect you against that. You'll just get a crap block when you decrypt. So if the server's not secure, you can decrypt and you will get a corrupted file and you won't know about it. So either using, I was thinking, well, obviously a hash, a HMAC, or GCM can protect against that. So there is a side advantage to that if your server gets compromised and you're using GCM instead of CVC, you'll get a number of users saying immediately all of these files are not decrypting, rather than people maybe saying that files have a corruption in them. Because if they're a large file, they may not notice the corruption for 6 months, whereas with GCM, they'll notice that it doesn't decrypt properly immediately. And you'll get a large quantity of people saying all of our files are not decrypting. The future for passwords is to also include any other information that can be bound and discovered from the client and server into the encryption process. So if you have document IDs or the sender's email, and then on the decrypting side, they need to have the same information, and that would be bound but not encrypted. So AEAD authenticated and bound data for that encryption file. The upside of that is then, again, it's not two-factor authentication, but it adds the ability that someone else is coming in and trying to break the system. If they don't have all of this information, then they can't actually decrypt the file anyway. So it helps against offline attacks in that way. It was proposed as a password future thing to have, again, this level of hashing that you do on passwords, to have the user be able to have a somewhat guided way of selecting that. I'm not entirely sure that that's going to be a workable thing. If you're telling people, if you do this, it takes a minute, but you might have security for 10 years because people have the misguided thought that if I'm encrypting with this, it lasts forever. And if you're saying only 10 years, they might frown on it or say, this is not quite what I was expecting when you said encryption. Unless you can sort of say, click here and have a generated password, and that circumvents this whole question. So moving to GCM side, the main gotcha to that is that if you're using the same key and you ever repeat an IV and you're generating an IV at random and you happen to repeat it, then your whole encryption falls on the ground. So to get around that, because you don't really, for AES-256, it's irrelevant to have a IV that's larger than 128 bits. So you generate a 96-bit random IV and then just have a incrementing or the actual chunk number in the file. And that way the IVs will never repeat for that particular encryption key. So that gets around that problem of, it's not so much a problem of GCM, but that issue when you're using GCM that you need to use it in a way in which your IVs are never going to repeat. Again, if people are AES or GCM people and they're encryption and security people and want to speak about this afterwards, because I understand that most people would be like myself a couple of years ago and think, GCM, that's fun, that's very interesting. I just want to send large files. So that is more or less what I was just talking about with the generating of entropy and encrypting. How are we for time? About half an hour in, or? I think so. Okay. The current encryption basically goes through and joins the IV to the data after it's encrypted the data. So each chunk, when you're encrypting it, includes the IV that was used for that chunk, which is then stored on the server, and the client gets the IV back. And if you have the password, you can decrypt it again. The old version of generate key just digested the password you've given it and imported that with the single import key call, which works fine on IE11, but not on, that works fine on IE11, but it's not an optimal solution. If you generate key 2018 version, which was from late last year, this code doesn't work on IE11 because it doesn't support derived key and it's Web Crypto API, and there's really no getting around that. But this will probably get advanced on because you get around the top line that's saying import the key with the PBKDF2, great name. That actually does the hashing. So if you have 1 million hash lines, that might take it 10, multiple minutes to do. But then you can reuse the same key, which can only be used to derive other keys. So, but the password hashing only has to happen once. And if you have 1,000 chunks to upload, you've got a significant time saving. At the moment, that's not being taken advantage of, but that is a really great reason to separate import key from the derived key call. And that's recommended by Mozilla and W3C to do it this way rather than the previous way. But this way doesn't work in IE11. So although, as I say, the interesting part is I would have thought mentioning IE11 so many times would have been really quite boring for people in here saying, I don't run IE ever, don't want to touch it, don't want to know about it. But there again, if you're sending a file to someone else, they may be using it. So it becomes relevant if you're getting research files from other people and that's what they're using, then that's what's going to happen. So being able to know that they're using IE11 and allow the system to still encrypt in a reasonably secure way for that setup is much better than saying, hey, use Linux. And then they say, hey, I don't want to. One of the pain points to the system is the language translation and website templating has sort of been shoved together because they seem like the same sort of thing, but they're not. And you're translating strings in the UI versus doing templating stuff. So I'm not entirely sure how to easily get around this from where we are. It uses a PO editor online web interface to allow you to do that. So if you're a language person, you don't necessarily need to be able to know how to handle the files or do GitHub pull requests and things like that. I pull it all in from the website, which is painful for me, but I can see how it's interesting for people who know languages but don't necessarily want to care about IT. Which I suppose is one of the, this is how you actually bring things in. One of the downsides to projects that are more at large scale. The CI, I've taken it from where it was, and it actually runs 5 Travis instances on every pull request. It does one database migration and runs everything on MariaDB 10.0 and whatever the Postgres is. Runs the core tests on that, which are console-based ones, and also runs an instance of Selenium on both. So you can see, for those who aren't familiar with Selenium, you can fire up a browser and control the browser from your CI unit tests. So you can say to the browser, go to this URL, click these buttons, make sure this happens. So you get some idea there that it's not broken, which some developers don't like doing testing. I'm quite a fan of it because I'd rather know that something's broken now than in 3 months' time when someone finds that it's broken. It's going to be broken no matter if I'm told about it from CI or someone else. Ultimately, I'd like to extend the Selenium test to include a bunch of browsers. So you knew in Chrome, you knew in Firefox, you knew in IE or Edge, or if it could run across 10 browsers in 5 different versions, I'd be all for it. It's a matter of finding the infrastructure to make that happen. Particularly the ugly duckling of Windows 7 and IE 11, because if it works on that, it seems to work on everything else. There's talk of doing a UI refresh a few times. I'd recommended moving to using Bootstrap so that you could more easily have a tablet version. And that's been floated a few times, which I wouldn't mind doing, so that you can be on a tablet and share to FileSender, and then have the credentials already there. And basically, if you have, because people take photos on tablets and things like that, and then can't necessarily email them to other people because they're too big, or video files. But yeah, that may actually happen at some point, either by direction of the board or by direction of me just doing it because I feel like it. I have a background in doing virtual file system stuff, so integration with endpoints, because some endpoints that you upload large files to don't have great upload, and I'd like to use FileSender on the server, have an option to say also CC this to YouTube or some other academic endpoint. So if you're uploading a file, the upload happens, and then you get an email saying, that's been uploaded, and that's also been shared with these people on this other system. Again, the talk of GCM, the E2E encryption. So on the plus side, although it's sort of probably a bit of a staggered spraying about, I'm going to do this with encryption, I'm going to do this with keys and stuff, there's probably, it's a plus side that there's so much interest and so many audits happening to make sure that the security is as good as it can be in this. There was mention, rather than my hacked username password thing, to allow small instances of FileSender to actually just use Apache authentication. So instead of using SAML, you can turn a config option and say, I know how to do Apache config, just do that. So any other options, you can configure SAML with a Windows domain. So if you've got a local, if you go that way, you can actually already set up SAML to authenticate against your logins. Already there's Amazon and the S3 backing in the cloud, so there's the potential of running the entire thing like the PHP and your database in the cloud, but I'm not, some people might want to do that, and I'm happy to allow that to happen, but I'm not, I suppose I'm more of a person who enjoys putting things in the cloud that are the second copy rather than the main copy. Session clone was a feature which I think would be handy if somebody's doing something and they run into trouble. They want to be able to email an administrator and say, can you have a look at that? And just leave the session running for a few hours, and the administrator can clone that whole screen over. Or just get to that particular, try and rebuild that UI and see what's happened. So if something's gone wrong, clone the session across, have a look maybe at the JavaScript console, some way of helping certain users out. It might be useful, but also it shouldn't happen. So it's kind of a, not sure which way to go there. And again, for the Docker images to actually allow people to deploy things. There is a page, and it mentioned earlier on that there was a 15-minute challenge of get FileSender going in 15 minutes or it's free, or, but it's free anyway. But it doesn't take 15 minutes. The SAML stuff, when I first looked at it to try and develop it with it, coming in with no exposure to SAML, that was a real stumbling block. Other than that, if you have Apache or MariaDB set up and you've got a PHP going, you should actually be able to get it up and running fairly easily. But maybe the Docker images will help that, and people wanting to run it up on a machine like this, for example. And, click exit. That's it. Excellent stuff. Alrighty, so questions, comments, fruit being thrown at me?
Thank you, Ben. We've got 5 minutes, so we'll take a few questions if anyone has any.
Cool. I'm interested in uploading large files that don't, like a large file each day, like a backup that doesn't change a lot. Any chance of an rsync kind of interface?
There was a couple of things that I was looking at that did that, where you could stipulate what the previous version was. and it was like a web version of rsync, if you like. Yeah, I'm interested in doing that. I certainly think, if there was a moderately formed pull request, I'd merge it pretty quickly. But if there's not, then I'm also interested in doing it. So, it's just a matter of what time frame that happens in. If if it's the pull request, it happens fairly quickly. If it's not, then yeah. But yeah, there's certainly stuff that lets you do that if you can say this was my previous one. So if you're only doing that for one user, then you could also default it to say whatever the last one was, just diff that.
It looks like a very useful tool. Any chance of a command line version so you could script this?
There's a REST client API.
There is, okay,
Yeah.
thank you.
And recently also, that was in PHP, and there's now a Python REST client. So.
Okay, that'd be useful for people who are working remotely and need to push large data sets from synchrotrons and things, so thank you.
One of the areas, because the encryption is all done in JavaScript, I was looking at possibly taking that and allowing that to run in Node.js, because then you'd be able to use the same encryption to upload, depending on if that's part of your use case. If you're not encrypting, I'd say the REST client could do what you want to do. So.
Any other questions? No? Okay. Thank you, Ben.